In this video we're going to look at pipe system appurtenances. An appurtenance is a component that's attached to a pipeline, so that can be a valve, a T, an instrument connection. These are the things that control the pipeline, that allow you to do maintenance and allow you to measure how it's all going. So and change direction too. So the first thing is fittings. They allow the pipeline to change direction. So you've got these bends and you've got T's as well. So the bends allow the pipeline to change direction. You can see them in plastic here. These are for solvent welding. UPVC pipes for solvent welding. Here's a cast steel, cast iron, which is it's got a flange connection there. So once again, 90 degree change of direction. This one's here's a 90 degree. This one here is a 45 degree. T's are for connecting pipes into pipes. So for example, you've got a 90 degree connection here for when one pipe's coming in there to connect to another pipe going that way, and that's what this cast iron one as well. So one pipe's going this way and one pipe's connecting into it. And then there's the 45 degree ones as well. So what this allows to happen is that the flow's going this way, and then the pipe connects in that way, and the water is coming in at 45 degrees, and so it is going to merge with the main flow much better than the 90 degree one, where there's probably going to be a lot of turbulence at the connection. So you'll find that house water connections, house wastewater connections use this 45 degree system rather than 90 degrees. Pressure systems, water main pipelines will use this 90 degree one. When you change direction, you put forces on the pipe that's trying to force it apart. So you can see the water's coming down like this. It's going up this way, and there is a force trying to push. The water doesn't like changing direction, and it's going to be trying to push that way. Now that can pull the whole system apart. Likewise, when you're coming over a hill, the water just wants to keep on going that way, so there's a pressure on this part of the system trying to force the fitting to go that way. Likewise, when you've got a gate valve, when you close the valve, the water is actually trying to push the gate valve over there. When you've got a terminal end where it's not going any further, once again the water is trying to push the pipeline apart. So thrust blocks take that force and transfer it to the surrounding soil, normally made out of concrete. So you've got a pipe coming around the corner here, and you can see the guys are just casting in a concrete thrust block, which will support the pipe against sort of pulling apart. So thrust blocks are like structural elements sort of holding the pipe together. The different types of valves, different things we want valves to do. We want them to control the system. We want to be able to increase flow, decrease flow, like a tap. We want to close off the flow to a particular area so that we can get in there and open it up and clean it, or remove blockages. So once again, the gate valves do that. We want to prevent backflow, especially with pumps. We don't want water, once it's being pumped up a hill, to come back and flow back through the pump. And we want to get air out of the line, especially in pressure lines. In pressure lines, you can't have air there because it takes up space. It decreases the capacity of the pipe, so you need to vent the air out of the system. So gate valves are really just like an enormous great tap. So you turn the hand wheel, and it forces the stem down, and it just screws down and then bonds with that. So that's made out of the gate's made out of rubber, EDPM rubber, and it forms a tight joint with that. When you want to open it, you just turn the hand wheel the other way, and the stem screws upwards and lifts the gate out of the flow of the water. So the water's flowing through here. This is cast iron normally. Check valves stop the water from flowing backwards, so you've got the water flowing this way normally. If the water wants, and that's a flapper valve there, so if the water wants to flow the other way, it's going to put pressure on that flapper valve and force it closed. So the water can flow that way, but the minute it tries flowing the other way, it's going to push the flapper valve closed. In this case here, it uses a little ball thing. So when the water's flowing this way, it'll push the ball up into this chamber here. If it wants to flow the other way, the ball will actually drop back down again and seal off that area around there. And that's a flapper valve view as well, so you can see it goes up and down, water can flow that way, it can't come back the other way. Air release valves are usually put at the top of the high point of a pressure line to prevent any air that might gather. Any air that's sort of produced from the pump or from changes in pressure will actually gravitate up to the high points of the pipe system, and that's where you put the air release valve to allow that air to get out of the system, otherwise it's going to reduce the capacity. And what you can see here is that it will let, if it's got water there, that float will lift up and close the valve. If there's no water there, it's just air, then that float is going to drop down because it's not floating on anything, and it opens up the valve and the air escapes. The water, when you open up that valve, is going to start going up again to fill the gap left by the air, and it will once again close the valve. Underground installation, I've showed you this picture before. So there's a water pipeline, you can tell it's water because it's blue, and there's a whole lot of that is a fire hydrant. I think that's for a meter. There's gate valve there to close it off. There's a T for another pipeline which is sort of going to go this way as well. And so you can see there's 3 gate valves there, 1, 2, 3. So you can block off either one, this pipe or that section of pipe or that section of pipe there. So looking at it from a different direction, there's those 3 gate valves. Underneath there is the T connection. There's the fire hydrant. So it's looking at it from the other side of the previous photo. And this is what it looks like when it's concreted over top. So there's the 3 gate valves, there's the fire hydrant, there's the meter, and there's that gate valve that sort of isolates it all. So you can see that once you sort of bring it out of the ground, you need little chambers down so they can access those gate valves and the hydrant, but it's all below ground.